Finding the end term of a sequence. Rule or formula, also known as general term. Some terms of a sequence were found after being given the general term, the rule or formula. In this lesson, the reverse is done. That is, given some terms of the sequence, try to find the formula for the general term. Finding the general term formula. Number 1. Given the sequence 4, 8, 12, and 16, we are tasked to find the general term or the formula for this sequence. Note that this method is applicable if you can get the common difference on the first try. It says that we need to find the common difference. Now, to find this common difference, all we have to do is to subtract the first term from the second term. So we have 8 minus 4, we have 4. Then 12 minus 8, we have 4. Then 16 minus 12, we have 4. If we do this on the first try, and if we get a common difference for the following sequence, then we could go to this method. Now see that you have 4 as the first term. Then all you need to do is to have n beside 4. Now we have an initial formula for this sequence. Now let's try to see if this formula will fit the sequence. Let's try to substitute the value of 1, 2, 3, and 4, and if we're going to get the following terms of the sequence. We have 4, we solve for first term, then 4 again, we solve for the second term, then 4 again to solve for the third term, and 4 again to solve for the fourth term. Now let's try to evaluate this. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and 4 times 4 is 16. On the first try, we already get the term that is given into this problem. So therefore, using this method, we can say that the formula or the general term for this sequence is a sub n is equal to 4n. Let me let me write this properly. Again, the formula could be a sub n equals 4n. Now you could use this formula to find other terms of this sequence. So this is the answer for this problem. Now let's try another formula. Again, remember that in this method, it is applicable if you can get the common difference on the first term or your first try. So let's do this. Let's try to get the common difference. 9 minus 5 is 4. 13 minus 9 is also 4. 17 minus 13 is also 4. On our first try, we get the common difference of 4. So let's proceed to what we're go to the next step. That is writing the 4 and putting an n next to it. Now let's try this formula if we can get the following numbers of the terms. So we have 4 multiplied to 1 for the first term, then 4 multiplied to 2 for the second term, 4 multiplied to 3 for the third term, and 4 multiplied to 5 for the, no, I am sorry, 4 multiplied to 4, let me erase that again, okay, that is 4 multiplied to 4 to get the fourth term. Now let's try to evaluate this. 4 multiplied by 1 is 4, and 4 multiplied by 2 is 8, 4 multiplied by 3 is 12, and 4 multiplied by 4 is 16. On our first try, we didn't get the same number as these terms of this sequence. Now let's adjust these numbers. What are we going to do with 4 to make it 5 as the first term? So we should add 1. Now what are we going to do to 8 to make it 9? So we just add 1 again. And to 12 to make it 13, we just add 1. And to 16 to make it 17, let's add 1. Now let's evaluate this. 4 plus 1 is 5. 8 plus 1 is 9. 12 plus 1 is 13. And 16 plus 1 is 17. Now we have the same number of the of the sequence in the given. Now let's do the formula. See this number 1 that we add. This is a constant one. So if this is 4n, all of this is 4n. So we should just add 1 to the first formula. So our final answer to this would be A. Sorry, same mistake again. Let me erase this. Okay, so the formula would be A sub n is equal to 4n plus 1. So you will do the adjusting part on this part of the lesson. So you can use this formula to get the terms of this sequence. So this is the general terms and this is the final answer. Last example for this kind of problem. Given the sequence -1, -4, -7, and -10. Again, let's try to check first if we can get the common difference on our first try. So let's do this. We have -4 minus 1. So we have -4 minus -1. That would be -3. So -3. So again, -7 minus -4, that would be -3. -10 minus -7, that would be -3. Again, we have the same difference on our first try. So now, what we're going to do is to use that -3 and put an n beside it. Now let's try to see if this formula will, if we use this formula, if we could get the following numbers. So that's -3 multiplied to 1, -3 multiplied to 2, -3 multiplied to 3, and -3 multiplied to 4. So this will be the first four terms. -3 multiplied to 1 is -3. The -3 multiplied to 2 is -6. -3 multiplied to 3 is -9. And -3 multiplied to 4 is -12. As you can see again, -3, -6, -9, -12 is not the same with the given sequence. So all we have to do is to adjust these numbers in such that this will become -1, -4, -7, -10 respectively. So what are we going to do with -3 to make it -1? So all we're going to do is to add 2 to become -1. Same as well with -6, we should add 2 to make it -4. We should add 2 to -9 to make it -7. And we should add 2 to -12 to make it -10. Now we have the same number as the given sequence. We have the same terms on the given sequence. See this 2, it is a constant number because it doesn't change to all the terms. So we just add here positive 2. So our formula for this term is a sub n is equal to -3n plus 2. We can use this formula to find all the terms of this sequence. Just copy this here. So that is the formula that is the answer for number 3. Now let's try another example. Now note, this method is applicable if you can get the common difference on the second try. Not on the first try, but on the second try. And how is that possible? And how is that matter? So first, let's try to get the common difference. So 6 minus 3 is 3. 11 minus 6 is 5. Then 18 minus 11 is 7. On our first try, we didn't get a common difference. We get different numbers. Now let's try again on the second try. 5 minus 3 is 2. Then 7 minus 5 is 2. So we get the common difference on our second try. So that is our common difference. Now what are we going to do with these two? To this though, what we're going to do with this is we're going to divide it by 2. So the answer would be 1. So now what we're going to do, instead of n, we will use n squared. So n squared, and we will put 1 here. So we have 1 n squared. To simplify, we don't need to put 1. We could just write n squared. Now let's try to use this n squared and see if we're going to get these numbers. So we have 1 squared, 2 squared, 3 squared, and 4 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now as you can see, these numbers are different from the given number. So let's adjust this number again. Now what are we going to do to 1 to make it 3? Okay, so we will add 2. What are we going to do to 4 to make it 6? Again, we just add 2. Then 9 plus 2, 16 plus 2. Let's see if we have a correct sequence. 1 plus 2 is 3, 4 plus 2 is 6, 9 plus 2 is 11, and 16 plus 2, sorry, this is 2, is 18. So as you can see, we get the same sequence, same number to this sequence. So our formula now is we put a constant 2 to the first formula. So that is n squared plus 2. So what we're going to do is to write the formula now. So a sub n is equal to n squared plus 2. This is now the general formula for this sequence. So hopefully you could follow the instruction. Again, another example. Now let's see if we can get the common difference on the first try. 9 minus 3 is 6. 19 minus 9 is 10. And 33 minus 19 is 14. So we didn't get a common difference on the first try. Let's try on the second try. 10 minus 6 is 4. 14 minus 10 is 4. On the second try, we get a common difference. So what are we going to do with this common difference? We need to divide it into 2. 4 divided into 2 equals 2. Now we need to put this 2 beside n squared. Again, if we get the common difference on the second try, we always use n squared. Unlike a while ago, we only use n because we get the common difference on our first try. Okay, now let's try to check if this is correct. So 2 multiplied by 1 squared, then 2 multiplied by 2 squared, then 2 multiplied by 3 squared, then 2 multiplied by 4 squared. Let's check if this is correct. 2 times 1 squared is 2. 2 squared is 4 times 2 is 8. Then 3 squared is 9 times 2 is 18. Then 4 squared is 16 times 2 is 16 plus 16 is 32. So we did not get the same number as the two. We didn't get the same number. So we need to adjust this. So to make 2 8 3, we need to add 1. To make 8 9, we need to add 1. to add 1, and then to add 1. And that makes this 3, 9, 19, and 33. So we have now the same numbers of terms like on this like the terms on the sequence. So we just add a constant 1 to our original formula. So to write it up, we have a sub n is equal to 2n squared plus 1. So this is our general term. This is the formula for this sequence. Again, let's go ahead to the next example. Let's check this again. 11 minus 2 is 9. 26 minus 11 is 15. 47 minus 26 is, that is 1, 21. Then 74 minus 47 is 74. Let's try to make this sure. Minus 47. So 14 minus 7 is 7. Then this will become 6. 6 minus 4 is 20. We have 27. So we did get the same difference on our first try. Let's do another one. 15 minus 9 is 6. 21 minus 15 is 6. And 27 minus 1 plus 21 is 6. So we get the common difference on the second try. Now what we're going to do with this 6, we need to divide it into 2. So we have 3. So we have 3, then we will put an n squared beside it. Why n squared? Because again, we use n squared if we get the common difference on our second try. And we get, go back to another example, we just use n if we get the common difference on our first try. On our first try, we use n. On our second try, we use n squared. So again, let's go back to this. So again, this 3 comes from this. 6 divided by 2 is equal to 3. So we get this 3. Now let's check this formula if it will fit to our sequence. So 3 raised times 1 raised to 2. 3 times 2 raised to 2. 3 times 2 raised to 2. 3 times, oh, sorry, 3 times 3 raised to 2. And this is 3. Mhm. I'm lost now. Just wait. Okay. Again, 1, 2, 3, and 3 raised to times 4 raised to 2. Now let's check this. I'm sorry, this is 2. 3, 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. Then 3 squared times 3 squared is 9 times 3 is 27. Now 4 squared, 4 times 4 is 16 times 3 is 70 is 40 48. Okay, so we have a sub 5, so let's try a sub 5. 3 times 5 squared is 5 squared is 25 times 3. The answer is 75. Now, this is not the same with the terms of this sequence. So what are we going to do is to adjust it. So what are we going to 3 to make it 2? We need to subtract 1, subtract 1, we need to subtract 1, we need to subtract 1, and we need to subtract 1. So 3 minus 1 is 2, 12 minus 1 is 11, 27 minus 1 is 26, 48 minus 1 is 47, and 75 minus 1 is 74. So we get this the same sequence, the same terms compared to the given sequence. So now, what we're going to do is to subtract negative 1 from this equation. And now we can get the final answer, that is a sub n is equal to 3n squared minus 1. So this is now the final answer. So that is how we answer this kind of question. Now, in the example number 7, an example number 7, this kind of problem can be answered using a trial and error and some guessing. All you need to do is to plot all the numbers here. So that is 2 over 1. 2 and 2 over 1 is the same. That is 3 over 8. Next is 4 over 27 and 5 over 64. Now all you have to do is to find a relationship to this number 1, 2, 3, and 4. Find any relationship from this number to this number in such a way that all of them could have the same formula. In this case, 1, if we're going to focus our attention to the numerator, we can say that in order for us to have a formula for this, we could say that that is 1 plus 1, the other one is 2 plus 1, the next one is 3 plus 1, and the fourth one is 4 plus 1. So that's the relationship on the numerator. Now let's see again what is the relationship on the denominator. So we can say that these denominators are perfect cube. So we have 1 cube, then 2 cube, and 3 cube. Sorry, it is the cube, and 4 cube. Now all we have to do is to change the parentheses, the number inside the parentheses with n. So we can get this n plus 1 over n cubed. So this is applicable for all of these numbers. So the formula or the general term is a sub n is equal to n plus 1 over n cubed. This is the answer for this problem. It's somehow tricky. You need to be more critical and you need to have some guessing and trial and error to answer this. Okay, that's all for this lesson. Hope that you learned something today and hope that you could answer all your activities in this kind of lesson. That's all for today. Bye bye.